First of all, I am currently a senior technical evangelist on the Windows Azure evangelism team. So we have about, I would say, 10 people that covers various topics, and some of them have already presented at this particular user group. I think Scott Klein has previously covered Windows Azure databases, and we also have folks covering some really new and exciting Microsoft technologies in Windows Azure, or our Microsoft Cloud technology that includes mobile services, being able to connect your devices such as your iPhone and Android phones and Windows 8 tablets to the cloud, and also we cover other scenarios such as line of business applications, virtual machines, or infrastructure as a service, and other topics that might interest you. So today, my topic is on Windows, running big compute on Windows Azure. So we will have a couple of, let's see, click on next. A couple of different topics. One is the Microsoft HPC project and the history of it. And then I want to talk about the latest release of Windows HPC Pack 2012, which includes a on-premise server HPC pack and also a product called the Windows Azure Scheduler, which allows you to basically perform resource scheduling on Azure itself without the actual server components. And then I would like to discuss the very exciting development on Windows Azure, which is the brand new HPC hardware in Windows Azure. Some of the SKUs include 120 gigabytes of RAM, which is quite a bit for all your big compute needs, and also look at the roadmap and future discussions. So at the end of the session, you'll probably be able to understand specifically on Windows Azure compute-intensive workloads, and also perhaps get some ideas to take some of your older compute-intensive applications and teach you some new cloud tricks. And then we have a few demos of some of the older HPC applications that I've developed, as well as ported to a modern, using a modern web interface. So first of all, let me give you a brief overview or the history of the Windows or Microsoft HPC team, so also known as the Big Compute team. So they started these projects in about 2004, and the first version they delivered was on Server 2003. What it did is allows you to run MPI or message passing library type of applications, or very much scientific related applications to use many nodes in a large cluster configuration. I think at that time it was supporting up to 200 nodes or so. And then we released version 2, which was 2008. That's when I joined Microsoft. And that version supported up to 1,000 nodes in terms of being able to configure and manage these machines. And I think we actually, at the time, built the world's top 10 machine in China, which allowed us to have, I think it was 32,000 cores to be able to run simultaneously. And we recently actually ran a large simulation in Windows Azure with 50,000 cores, and we haven't even gotten started with the experiments yet. So there's a lot of exciting new development in large compute or big compute at Microsoft. And then we started supporting Windows Azure since about 2010. With our first version, supporting. I'm hearing a little bit of echo. Let me actually mute someone here real quick. See if that helps. Yeah, that definitely helps. Apologize for the echo sound there. So we supported a version. I think it was SP2 of Windows HPC Server 2008. So that particular version started supporting something called Azure Burst, which allows you to connect or simply add Azure nodes to your Windows HPC cluster to be able to burst into the cloud. So that's that's actually the first version. And then later on, we recently released a version, which was in November. That was Server 2012 patch to support Windows Server 2012, and be able to allow you to connect to Windows Azure nodes as well as Windows 8 as a client to be able to do cycle stealing type of work. And the team actually moved from Server and joined Windows Azure team in summer of 2011. So meaning that we are entirely in Windows Azure team, so be able to support these large compute scale type of workload for our customers. So I just want to very briefly describe what big compute is. So big compute is really about taking an application that perhaps runs too slow or a single computer aren't be able to handle, and split the work up and move them into multiple machines to be able to do. So as in the 90s, people started building these really large Linux clusters. I think the world's largest one is now the machine Jaguar in Oak Ridge National Lab. I think it has in the orders of almost 1 million cores. So that's in the extreme in terms of government-sponsored projects that are or really large institutions that being able to afford hardware like that. So in terms of the rest of us, so small universities or maybe companies, that these institutions also started building small clusters. So a typical one is about 16 nodes, meaning that you have 16 computers clustered together to do a lot of work. So in 2006, when we first released our product, there's a lot of institutions started using that as their main compute resources to be able to manage a large cluster. So I also would like to call big compute as something called no idle computing. So meaning that you're trying to resource manage your investment so that it's not doing idle computing. So it's not just simply sitting there. And this applies really well in the cloud scenario where you can simply go spin up a cluster in the cloud and then turn it off when you no longer need it. So there are two important aspects of this. One is resource management tool that allows you to monitor and manage resources for your cluster, and the other one is a batch scheduling tool. So basically, you may have lots of users and you may have lots of applications that are competing for resources. So you may have to schedule them or queue them up so that they are using the resources efficiently. So how does Windows Azure extend high performance computing to the masses? So the development of Windows Azure or cloud computing in general has started to provide businesses that don't necessarily have access to large clusters or don't necessarily want to build a large machine and perhaps only use it once or twice during the year. So for example, one of the insurance company that we work with, they tell us that only around hurricane seasons would they actually be using the compute for maybe, I would say, 3 months out of the year. So the rest of the time, the compute clusters are simply turned off or not being used. So that actually end up costing a lot of money because you have to maintain a full staff to be able to do management on your cluster. And also you have hardware and also real estate. Nowadays, for a lot of these financial institutions, it's more about real estate, not being able to have the power and the hosting facility for these large machines. So that becomes a huge problem for them. So cloud is what a lot of these large businesses and even smaller businesses are very much interested in. Access to large amounts of compute resources. On Windows Azure, you can get up to 320 cores in a small subscription, as that is my subscription. And for people who really want to use large amounts of resources, such as our testing team, they use up to 50,000 to 100,000 quarterly when they do scalability testing. And also, this is a pay-as-you-go model, as I said. If you use your cluster only a couple of months out of the year, then you only care to pay for those, and then it ended up saving you lots of money.